Hi children, how are you all? I hope all you are fine. Children, what we discussed in the previous video we discussed about that representation of rational numbers on a number line. Along with that, how many rational numbers are licensed between any two given rational numbers. About those two we discussed in that previous video. No? In this video, we are going to discuss about that inserting rational numbers in between any two given rational numbers. Okay ma, what is that next one? Inserting or insert rational numbers in between any two given rational numbers, any two given rational numbers. Okay ma, this is the next sub concept. Here children see that here actually we are having the three methods ma. One is by taking that LCM. Okay, by taking that LCM you will get that denominators are same, no? Then here see that, let us take that two rational numbers are 3 by 5 and 4 by 7. 3 by 5 and 4 by 7. Now here see that the first method, what is that first method here? By taking the LCM. Okay, see here, what are the given rational numbers here? 3 by 5 and 4 by 7. First take the LCM of two given fractions. Okay, now here take the LCM. LCM of 5 and 7 is how much you will get here? 5 and 7. That is 5 sevens 35. 5 sevens 35. Now here 3 by 5 is the first rational number, no? And here the LCM is 35. Then here 5 into how much is equal to 35 ma? 5 sevens 35, 3 sevens. Okay, by the same number we should multiply both numerator and denominator, no? That's why. Here see that 3 sevens 21. Clear? 21 by 35. 21 by 35 is the equivalent fraction of 3 by 5. Yes or no? Yes. And 4 by 7. Okay. Then here 7 into how much is equal to 35 ma here? 7 5s 35. 7 5s 35. And here numerator also we should multiply with the 5. Then here 4 5s 20. Okay. 20 by 35. And here 21 by 35. Now here see that we are having those two numbers also, 20 by 35 and 21 by 35. Again we are having that in between 20 and 21, how many rational numbers means? We will get that so many rational numbers. Okay. Then here first I want to multiply that 20 by 35. Both numerator and denominator I want to multiply by some 2. Then how much you will get ma here? 22 is 40, 35 to 70. Okay. And in the same way 21 by 35. I want to multiply again both numerator and denominator by the same number. Then here 21 twos, that is 42. And here 35 to 70. So which number is lies in between 40 by 70 and 42 by 70 ma? See here. Therefore, rational number which is lie in between 40 by 70 and 42 by 70. 40 by 70, 42 by 70. In between which number is there ma? In between 40 and 42 which number is there? 41 by 70. 41 by 70. Okay, this is the number which is lies in between 40 by 70 and 42 by 70. Understood? After cancellation or you will get that decimal numbers. By taking the decimal numbers also you will get that infinitely many rational numbers in between any two given rational numbers. Okay. And in the same way here I will tell you one more method, see that. Second method. How many rational numbers are lies in between? How many rational numbers are lies in between -2 and 1. or minus 2 and 2? Minus 2 and 2. Here see that minus 2 is a rational number, we know that. Okay, how to take that minus 2 as a, how we can represent that minus 2 as a rational number? By taking 1 as the denominator, we can represent that. Okay, now I want to multiply both the numerator and denominator by 10. Okay, then how much I will get here? Minus 20 by 10. Minus 20 by 10. And in the same way here, 2 also. 2 also we can represent as a 2 by 1, which is also multiplied and divided by 10. Then you will get it as 20 by 10. Again 0, 0 cancel. After again you will get it as minus 2 only. That is equivalent fraction only, no? Yes. And here also 0 and 0 gets cancelled. Again you will get it as 2 only. Yes or no, ma? Yes. Now here see that rational numbers lies in between. Rational numbers lies in between minus 20 by 10 and 20 by 10 are. Here see that infinitely many rational numbers we can observe that. See that minus 19 by 10, minus 18 by 10, minus 17 by 10 and so on. Here see that. Why? Because here minus 1 by 10, minus 2 by 10 like that only, no, you will get. And here up to that minus 1 by 10, 0 by 10, after that 1 by 10, 2 by 10, 3 by 10, 4 by 10 and so on up to 19 by 10. Clear, ma? Just observe that these all are the values lies in between minus 20 by 10 and plus 20 by 10. Okay, here we got that more numbers, right? And in that previous method we got that one number. One rational number lies in between any two rational, given two rational numbers, 3 by 5 and 4 by 7. Now here see that like these numbers they given means just by multiplying and dividing by the same number, then you will get the equivalent fraction. Okay, ma. By taking that equivalent fractions, then you can find that the numbers which are lies in between the given two rational numbers. This is one of the method. Come to that next method, that is the formula method. Okay, ma. See that. Okay, exactly in between which number is lies in between? Exactly in between two given rational numbers, exactly in between which number is lies, which number is lying. Okay, now here see that let A comma B are any two rational numbers. Any two rational numbers, then the rational number which is exactly, then the rational number which is lies in between, or else which is lying in between A and B is A plus B by 2. This is the formula method, ma. What is that? The rational number which is lies exactly in between any two rational numbers means here the formula is A plus B by 2. Okay, here I will tell you that example. See that let A is equals to 3 by 5, B is equal to 4 by 7. So in between 3 by 5 and 4 by 7, which rational number is there? Okay, by taking that, see here what is the formula here? A plus B by 2. Here A is equal to 3 by 5 plus B is equal to 4 by 7 whole by 2. Okay, ma. Just to simplify the numerator here, what is that LCM of 5 and 7 here? Again we have to take the LCM of 5 and 7, that is 5 sevens 35. Next cross multiplication, 3 into 7 plus 4 into 5. Already you know that how to add that fractions. Okay, ma. By applying the same condition here, whole by 2. Okay, which is equals to 3 sevens 21 plus 4 5s 20 whole by, and in the denominator also we are having that number means we can write it as 2 by 1. So we can multiply with its denominator 35 by 2. Sorry, 35 into 2. Okay, now here 21 plus 20 which is equals to 41 by 35 into 2, which is equals to 70. At that starting, we got that the number which is lies in between 3 by 5 and 4 by 7 means we got that 41 by 70 only, no? See that here. Here we got that 41 by 70, no? Exactly in between. Okay. So this is one of the method, and this is by applying formula also we will get that number 41 by 70. Which is lies in between, exactly in between. Exactly in between means here 3 by 4 and 4 by 7. 3 by 5 and 4 by 7 exactly in between. Okay ma? Yes. So this is another method. Actually here we are having that by taking the decimal method also there. Okay. Once I will explain you here, see that decimal method means in between 3 by 5 and 4 by 7, okay, by taking decimals, so by taking decimals, how to simplify this one? See here, 3 by 5, okay ma, 3 by 5, what is the meaning of 3 by 5? 3 divides by 5, 3 is less than 5 only, no? That's why here keep that 0 and here also keep that 0.5630. Okay, 30 minus 30 is 0. Okay, then here how much you are getting ma? Which is equal to 0.6. Exactly we are having 0.6. And 4 by 7, which means 4 divides by 7. Okay, again 4 is less than 7 only, no? That's why keep here 0 and here 0.7535. Okay ma, 40 minus 35 which is equals to 5. Till again here 0. 7 sevens 49. Okay, here 50 minus 49 which is equals to 1. Again if you want to keep that means again you will get it as 0, which means that is 10. 7 1 7, again you will get it as 3 as the remainder. So this is a non-terminating decimal you will get here. In the rational numbers already we discussed, no? This one you will get it as a non-terminating decimal. But I want to take up to 0.57 only, that is sufficient. Okay. Then here 4 by 7 which is similarly equals to, that is 0.57. Similarly equals to 0.57. And this is a point after only one decimal place here we have, no? Just write it as 0.60. Okay. Now here how many rational numbers we can write? 0.58, 0.59. These two numbers lies in between 0.57 and 0.60. Actually these two are the given numbers. In between these two numbers here we are having that 0.58 and 0.59. By taking that 3 digits also, 3 decimal places also, we can write that infinitely many rational numbers we can express. See here, by taking that 0 here, 7 ones is 7. So here I am going to take that 3 decimal places. Then what you will get ma here? See that 0.571. Okay, which is similarly equals to 0.571. 3 decimal places, no? And this is exactly terminating decimal. That's why 0.600. 3 decimal places. Now here how many rational numbers are lies in between 0.571 and in between 0.600? Okay, how many ma? In between 0.571, after that we are having 0.572, 0.573, 0.574 and so on, 0.589, 0.590, 0.591, 0.592 and so on, 0.599. After that we are having 0.600. Okay, in between these two numbers here we got that infinitely many numbers, no? That's why here what we can conclude ma here, in between any two rational numbers we are having that infinitely many rational numbers. Okay, and this is a decimal method. Mostly in that last exercise, that is worksheet 5. Okay, the total we will discuss about that. By using decimal method, this is easy to find that the rational numbers which are lies in between any two rational numbers. Okay ma, see that. After that we are having a decimals concept is there. So decimals concept we will discuss in that next video. Okay, thank you all.